Okay, thank you very much, Gerd. Very nice for this early morning at your place. I think there are some, so we are running late, as you had mentioned, so it would be good that we have maybe one question or two questions, and Tom, would you just really select one of them, which we got during the talk?
Yeah, I could select one question of Baron Mons. He asked a question very specifically, if you use in your database also the globally unique resolvable identifiers.
I don't know if that refers to the DOI of the papers.
No, for the globally unique resolvable identifiers, he means, for instance, SMILES, INCHI codes, and or UPAC identifiers.
Oh, well, the SMILES so these are inorganic materials. So the SMILES codes are for organic materials, right? If I understand. So there are, I don't think there is a set of unique identifiers. All we do at this point is link the inorganic compounds. So the reactions are linked to the DOIs of the papers. And then in some cases, the compounds are linked to the materials project IDs. So you can extract thermochemical information if they are available in the database.
Yeah. And another question would be, this works for solid state synthesis in bulk form. Would it also be possible to use this analogy with thin film synthesis?
Yeah, I don't see any reason why it wouldn't work, right? So when you do the specific extraction of the synthesis recipe, there's a little bit of retraining necessary because there are other keywords, other techniques that the algorithm has to learn the terminology about. So that's, for example, what we did when we go from solid state to solution-based synthesis. Most of the algorithm is the same, but there's some retraining on the actual extraction. For example, a thin film synthesis, you know, it may be important to extract things like substrate, that it's done on substrate temperature. So you have to identify those as extractable and learn that, but it's fundamentally quite similar.
Another very interesting question comes from Rampi Raprasad. He is asking if it's also possible to include negative results from synthetic chemistry into your machine learning techniques.
Well, it would be if they were published, right? But they are unfortunately almost never published. So it is a real problem, and I think it leads to that question that I brought up, that it's very hard to do an existence proof for synthesis because there are no negatives. I think all we can do is sort of saying, if you could make this, this would be the way to make this. I mean, people have done negatives in the literature, but only from collections of their own lab notebooks, right? So if you have 1,000 reactions you tried in the lab, which few of us have, and you have the negatives, then you can include that. But nobody's been able to do it on a sort of massive, you know, scale of data published by the scientific, you know, community, because there are very few negatives.
It would be more recommendable to include this in our publications, perhaps.
Yeah, yeah. And occasionally we use information. Sometimes people say, well, you know, I tried from 500 to 1,000 and we only got this at 750. We store that information now, but we don't really use it yet because there's simply not enough of that.
Yeah. So these were the important questions that I see, Matthias. A very interesting talk, and also get very positive comments here on the chat.
Great, thank you very much.
I agree. There are actually several more really very good questions, but I think we have to answer them later, or actually Gerd has to answer them later. And I think we have
yes, you're welcome to get them to me at some point. So thank you.